And we will now wrap it up with the last, 15 questions, something like that. These two should be very straightforward. Determine whether each function has a max or a min. You just look at one place. You look at the coefficient in front of the x squared. If it's negative, that means it's shaped like this, and you have a maximum. If it's positive, like it is in 68, it means you're shaped like this, and you have a minimum. So it just feels backwards, but this is the right way. A negative coefficient means a max. A positive coefficient means a min. Okay, on 68, we want the vertex. The vertex is this point right up here, where it changes the direction, because you think about it, this graph is going uphill, 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 then boom, downhill. So that's that ordered pair right there, -2, 2. The axis of symmetry is the vertical line that goes through the vertex. So it always corresponds to the x value in the vertex. So the axis of symmetry is the vertical line, x equals -2. The y-intercept is where it hits the y-axis, which is right there at 0. These zeros, that's the same thing as the x-intercepts. That's where it hits the x-axis. So we have two of those, -4 and 0. It says find the y-intercept of the graph of each function. The y-intercept is the number that has no variables with it. It's the constant. So in this case, it's -6. Over here in this one, it is +8. Okay, solve each equation by factoring. So factoring is step 1 on these, or at least most of these. Then setting the pieces or the factors equal to 0 and solving is the next step. So on 72, rule number 1 of factoring is to see if there's anything both pieces have in common. Well, they're both divisible by 7, and they both have an x, so I pull out 7x. So I took away that 7 and one of its x's, so that leaves just one x left. -14 divided by 7 is -2, and we took away its x, so it's just 7x. It's just x minus 2. So that, like I said, is step 1, factor it. Your next step is to set each piece or each factor equal to 0 and solve for x. So you divide both sides by 7 here. 0 divided by 7 is 0. You add 2 to both sides here. 0 plus 2 is 2, so x equals 2. So what we're really saying is that if you plug x into this equation, I didn't say that right. If you plug 0 in for x in this equation, the result will be 0. If you plug 2 in for x in this equation, you will also get 0. So there's two numbers you can plug in for x that will make this equation equal 0. Okay, 73. This is the special case we talked about that has two perfect squares. This is called the difference, meaning we're subtracting, of squares. When you see that pattern, you know you just take the square root of the first term, square root of 25 is 5, square root of y squared is y, and you put that at the front of both sets of parentheses. Then you do the square root of 49, which is 7, and you put that on the back of both sets of parentheses. Then you put one of them minus, one of them plus. Doesn't matter which one you put first or second, just make sure you have one of each. Then you set this term equal to 0, add 7, divide by 5, and you get y equals 7/5. Then you set this factor equal to 0, subtract 7, divide by 5, and you get -7/5. So if you plug either of those numbers in for y, it will make this equation equal 0. On 74, they've already done step 1 for us. They already have this factored. So you don't need to FOIL it. We want it factored. So this one's shorter and quicker than the others. You just jump to step 2, where you set each factor individually equal to 0. So on this one, you add 9 to both sides. You don't. You subtract. Subtract 9 from both sides. Then divide both sides by 2. So you get -9/2, or -4.5, same thing. Then you set this one equal to 0, add 6 to both sides, and get x equals +6. So if you plugged either of these x values in for this equation and for x, then you would get 0 as the result. 75 is another one like 73 that has a difference of squares. We can take the square root of a to the fourth and the square root of 81, and we're subtracting. So it's the difference of squares. The square root of a to the fourth is a squared. We put that on the front. The square root of 81 is 9. We put those in the back. We do 1 plus, 1 minus. Doesn't matter what order. Well, this is no longer a difference of squares because it's adding, not subtracting. So we can keep it, but it doesn't factor any further. But this one is another another difference of squares, because we can still take the square root of, try again. We can still take the square root of both of those, and we're subtracting. So it's a difference of squares we can do again. Square root of a squared is a. Square root of 9 is 3. Then we give 1 a plus and 1 a minus. Now it turns out this one will never equal 0. A squared plus 9 can never equal 0. Now think about it this way. I told you, anytime you square a number, it's always positive. There's technically one exception. If you plug in 0, 0 squared is 0, and 0 is neither positive or negative. But that means the smallest this thing can ever be is 9. Well, you can't equal 0 if the smallest you ever are is 9. You can also show it by setting it equal to 0, subtracting 9 from both sides, so you get a squared equals negative 9. But we cannot take the square root of a negative number. There is no number that if you multiply by itself results in a negative answer. But these two, they're pretty simple, so I'll just point them out. You can set them both equal to 0. You'll get negative 3 and positive 3 as two answers. So it was correct to find 3 factors. There's nothing wrong with what we factored. It's just that not every factor can equal 0. Most do, but there are some that don't. Last page. Okay, to factor, we need it to be set equal to 0. So we add 16 to both sides. Then we say, what will multiply to be 16, positive 16, and add up to negative 8? And that would be negative 4 and negative 4. So we have x minus 4 times x minus 4 equals 0. Now this is a case where both factors are identical, so I don't really need to write both of them set equal to 0, because obviously I'll get the same answer either way. So I just set x minus 4 equal to 0, and then you add 4 to both sides and get x equals 4. Here we have 3 terms, so we'll do bottoms up because of this number in front, because there is nothing all of them have in common. 4 times 9 is 36, so what will multiply to be positive 36 and add up to negative 12? Well, that would be negative 6 and negative 6. So I've got x minus 6 times x minus 6. But that 4 we tried to kill and get rid of has come back and is trying to divide and conquer us. Here's a common mistake people make. They say, oh, that won't be a whole number. I'll just bring the bottoms up. No. You'll always have to reduce the fraction, if possible, first. So my next step is to reduce the 6 over 4 to 3 over 2. Then I can bring that 2 bottom up as a coefficient in front of x. And just like the previous problem, we got the same factor twice, which is okay. It happens sometimes. So we just have to set one of them equal to 0, add 3, divide by 2, and we get x equals 3 halves. So on these last two, 76 and 77, there's actually just one single value of x that will make the equation equal 0. Whereas on the ones we did before, there were 2 values of x that could make the equation 0. 78, solve by completing the square. When we're completing the square, we want the constant over by itself on the right-hand side. So when I was factoring, I wanted it to be in this form so I equaled 0. But when completing the square, we want the x's on the left and the constant on the right. Then we do the magic, half the middle and square it, half the middle and square it. So the negative 8 is the b, so to speak, and that's considered the middle. So half of negative 8, I should have had a negative, forgive me. It doesn't change the answer, but negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. So we need to add 16 to both sides. That gives us this answer, or this line right here. Then we need to figure out what will multiply to be 16 and add up to -8. That'll be -4 and -4. And since those are identical, I can actually combine them and say x minus 4 squared, because squared just means times itself. And if you recall, I told you that when you're completing the square, so I'm only talking about completing the square, this value right here is always half of this one. So it's halfway through the half the middle and square it. This one's always the half the middle. So it's going to be -4, because that's half of -8. So we take the square root of both sides to get rid of that squared. We have to put plus or minus the square root of 6. And then x by itself, we add 4 to both sides. And there's no way to reduce the square root of 6, so that is our final answer. Okay, same process with 77, except we do have to subtract that 10 over first, because we want all the constants on the right side before we do the half, the middle, and square it dance. Yes, I said dance. So we have x squared minus 6x equals 9, because we subtracted 10 from both sides. Then we half the middle, so we get -3. We square -3 and get 9. And then we'll add 9 to both sides. And that gives us this equals 18. So I went ahead and skipped, because we know the whole point of completing the square is so we get the same thing times itself. And we know that it always ends up being half the middle number. So I said x minus 3 squared. Then you have to take the square root of both sides to get rid of the squared. You don't need the parentheses right here. I'm not sure why I wrote them. So we get plus or minus the square root of 18. Now that can be reduced, because 18 is the same as 9 times 2. The square root of 9 is 3, and the 2 just stays inside because we cannot take the square root of it. So the square root of 18 is the same as 3 times the square root of 2, and I do have to put plus or minus in front of it. Then my last step to get x by itself is to add 3 to both sides and get this is my final answer. Okay, number 80. We are using the quadratic formula, and I will provide this formula for you on the exam. You don't have to memorize it. With the quadratic formula, like factoring, we want it to be equal to 0. So you can't pull a, b, and c out right now because this is not in the right position. So we need to subtract 15 from both sides. Now we can say a is 3, because that's the coefficient in front of x squared. B is 2, the coefficient in front of x. C is -15. And I've heard a couple of you ask this, so I want to make sure you remember. A, B, and C never contain a variable. A, B, and C are only numbers. They're just the coefficients. So I plug in -b plus or minus the square root of b squared minus, see if I can get this visible for you. There you go. Minus 4 times a times c, all divided by 2 times a. So if you want to pause just to see where I put all these numbers in, you can. I went ahead and squared the 2 and got a 4. Multiply these together, you get plus 180. And I did 2 times 3 equals 6. 4 plus 184, no, sorry, 4 plus 180 is 184. And I know this isn't a really common one that you're going to have to reduce, but 184 is the same as 4 times 46. So that's how I was able to reduce that. Square root of 4 is 2, and the 46 stays inside. You know, stuff that we've reduced on other parts of the test may show up. I wouldn't expect one that hard for the exam. So then we get -2 plus or minus 2 square root of 46, all divided by 6. And since those are all even numbers, we can divide all of them by 2. And we get that as our final answer. The last one, 81. This is in the correct form already. It's all equal to 0. So I can pull out my A, 5, my B, 7, my C, 2. You can see the formula here. I do negative b, so that's negative 7, plus or minus b, 7 squared, minus 4 times a times c, all over 2 times a. 7 squared is 49. 4 times 5 times 2 is 40. 2 times 5 is 10. I had to make a correction to an error I made here. The reason this is scribbled is not because this is wrong, it's just it's not the final answer. So 49 minus 40 is 9. And then the square root of 9 is 3. And you can just leave it that way as your final answer for the entire spring exam review for Algebra 1. It's been a pleasure, guys. Study well.